Okay, good afternoon, everyone. Good afternoon again. How are you? Okay, hopefully you are doing okay today. So, I hope the class that is from group one, okay, everyone will be here. Don't forget to mark your attendance in Putra class, yeah, for the group one lab class, okay. So we have finished the lab for 2107 because I have to cover the lipid. So it is 4 hours. We will do 2 hours today and then another 2 hours tomorrow. Okay, for those who cannot come tomorrow, you can watch the video. For tomorrow is going to be the group two lab class. All right. So part of the important macro component that is we have to learn for food chemistry is lipid. Lipid, we're talking about fats because fats, as we know, lipid is a lot of food has the fat component, and fat component also affect many shelf life. We're talking about how fats are very prone to oxidation because of the later we will see because of the double bond. So you see that more saturated fat are more stable in terms of the reaction to oxygen as opposed to the unsaturated fat. Okay, what it means by unsaturated fat, what it means by saturated fat, we will see. We also see normally when we say lipid, okay, we have two types of terms that we use, which is oil and also the solid. Okay, when we say solid, examples are like butter. You see the margarine, butter. Those are solid at room temperature. We're talking about room temperature. Okay, when we say oil, those are the one that we use mostly for cooking, for frying. Those are lipid in liquid form. Okay, so two types of form, and there are so many different types of lipid that you will learn as we go along. Okay. Okay, so what are lipids? When we say lipids, the definition, it is a natural substance. So you see that all or mostly living organisms, either it is for food or non-food, naturally they will consist of lipids in the body or in the, when we say food, naturally occurring food, we will have lipid storage, for example. So when we say lipid, it is non-soluble, non-soluble in water, because of the nature of the lipid. When we say it is, when it is not soluble in water, it will be soluble in non-polar organic solvent. What it means by non-polar organic solvent? Non-polar organic solvent ni macam, for example, we have hexane, kan? Hexane is normally being used as a solvent. It is non-polar. Okay, when we see, if you can Google or if you are familiar with organic chemistry, okay, when we do extractions for natural component, you have to know what kind of chemical that you're going to extract out. Okay, then we have to choose what kind of solvent we are going to use. So if we want to extract out the lipid component of, for example, non-polar component, which is more of a lipid component from a plant or from a food, we have to use a non-polar solvent. Okay, so if you Google, you can see a lot of solvent that is being used, but the most effective one will be the non-polar. So you will see that it is being organized through the polarity. Like for example, methanol is miscible with water. So if you mix methanol and water, they can be mixed, right? So you can see that it is quite polar. So you have ethanol, and then we use. Do you remember the solvent that we use to extract lipid during lab when we did the proximate analysis. That is another solvent that we use. Last time we use PET ether, right? Petroleum ether. Petroleum ether is also another non-polar organic solvent. So that's why we use that for extraction of lipid during proximate analysis. Okay. However, there are a few exceptions for the definition of this insoluble in water because lipid consists of many fatty acids. Okay, when we say fatty acid, it has chain of fatty acids, short chain, medium chain, and also long chain. Okay, when we say short chain fatty acid, it is quite small in the C carbon number. Okay, so some of the short chain fatty acid, they are quite water soluble because of the size of the carbon short chain. Okay, and then we have trans fatty acid, trans and cis fatty acid. They are different in terms of how those if you go back to your chemistry class, okay, then the location of this functional group is located in the structure will define whether it is cis fatty acid or trans fatty acid. Trans fatty acid. So trans fatty acid are more water soluble. Okay. And then synthetic fat substitute. Synthetic fat substitute ni banyak a lot of companies use it for because fat, natural fat is actually quite expensive. If you see fat from cocoa butter kan, cocoa butter, you see that cocoa butter is being used a lot in cosmetics now, right? Because of that reason, even for cocoa butter, if you actually read the ingredient when you take the chocolate, okay, if you go for a very expensive chocolate, you can see what is the percentage of cocoa butter is being used. Cocoa butter is one of the most expensive butter. Okay, if you go and buy the like more cheaper chocolates, and you can see that they use a lot of fat substitute. That means either they use a very little percentage of cocoa butter, or they totally change the cocoa butter the fat percentage using fat substitute. As long as it can give the same structure, but of course you can for those who value or know, especially for trained panelists, they will know the difference between whether the chocolate use cocoa butter or the fat substitute. All right. And then FDA uses definition based on total lipid expressed as triacylglyceride or triglyceride, we call it. Okay, so the total TAG, triacylglyceride, and express it as calorific value, meaning the calorie. Okay, avoiding inclusion of non-calorific fat substitute. Okay, so if you see when we are talking about lipids, we normally scientifically we normally call it triglycerides or triacylglycerides. Okay, TG or TAG. Okay. All right, and then this is the classification of lipid. So we have derived lipid, simple lipid, and also complex or conjugated lipids. So derived lipids, that means the unit which is from larger lipids are being built. Okay, for example, fatty acid, alcohol. Alcohol can also be part of the derived lipids. Okay. For simple lipids, it is hydrolyzed. Hydrolyzed meaning the breakdown. Okay, breakdown to two components, usually alcohol and also acid. The examples are acylglycerol, ether acylglycerol, sterols. Selalu kita dengar sterols ni dalam formulation like plant sterols kan. So these are actually simple lipid. Wax also can be found in plants and wax esters. Okay, and then we also have another one which is conjugated lipids. So hydrolyze to 3 or more components. So break down to 3 or more components. For example, phospholipid. Phospholipid ni the other phosphor group that is combined together with with lipid. Okay, they also have glyceroglycolipids, or we call it glycolipids. Glycolipids ni, glyco means component of sugar. Okay, so it is combined with lipid, and we also have sphingolipids. This is like a combination of not just lipid with other functional group. So when they combine, it becomes a more complex structure. So we call it complex or conjugated lipids. Okay, so this is what I was mentioning just now. When we talk about types of food lipids, okay, so we have the fats and also the oil. Okay, when we say fat, normally we are referring to the physical fat, which is the solid fat at room temperature. Okay, we don't call oil fat normally. Okay, although both also means lipids, right? But normally we call the like lard, okay, lard, butter, tallow, these are all fats. In physically, it is solid at room temperature. Okay, for this type of fat, mostly they are from animal origin. Okay, like butter normally from milk. Okay, butter we made it from milk. Lard is from swine or from pork, and tallow is mostly animal fat lah. Animal fat from beef or from goats and whatnot. Okay, all right, and then this type of fat, why is it solid at room temperature? Because they contain higher component of saturated fatty acid. Okay, saturated fatty acid meaning that all of the bond in the fats, they are mostly saturated, means there's no double bond. It's more single bond. So when they are saturated, they are not prone to oxidation. So they are more stable. Okay, they are more stable. So that's why you see a lot of butter, they are quite stable at room temperature. Lard, so these type of fats are being mostly used in food, for baking, for example. Okay, and then there is another type which is oil. So when we say oil, we normally referring to fat, to lipids that is liquid at room temperature. So like palm oil, olive oil, then those are what do you call it, liquid at room temperature. Okay, later in part 2 we will see processing. During processing, in processing, we or the manufacturer normally we can actually change the oil to become solid at room temperature. So that's why when you buy spread, kan kalau kita pergi supermarket, okay, you go to supermarket and then you see you want to buy spread apa, butter lah, we call it butter or margarine that we want to put on the bread, right? But there are so many different types, kan, ada yang sunflower, ada yang olive, kan, but you think that olive actually is oil, right? How do they make olive become solid? So that's a process of making it. Nanti part tu kita tengok. We will see how some food manufacturers change the oil component of lipid to become the solid, so that it's easier to spread. Kan sekarang ni kita tengok banyak. If you buy pure butter, okay, if you like to cook, for example, right? So when we want to use the butter, the pure butter, for spread on the bread, or we want to use it for baking, normally you have to put at room temperature for it to become softer, right? So for baking, normally we will use soft butter. We don't use the hard butter, right? But now food manufacturer, they you can see in the supermarket the fat the section where you used to buy all these cheese and whatnot. You go over there and you can see all these new products that are coming. You have the spreadable butter. So how do they make butter more spreadable? Okay, so there will be processing involved, or changing of the chemical component of the fat or the lipid so that it is more likable to consumers. Normally kalau kita nak sapu dekat roti, we want it to be able to spread it directly when we take out from the fridge kan. After a while, if you put the spreadable butter on at room temperature, nanti when you open it, it will become more oily. Then you don't like consumer doesn't like that kind of texture lah. So normally, so this is what manufacturer has been doing. So they try to tackle the issues of this fats versus oil room temperature, and at the same time they will use this because for consumers normally this kind of oil they are more healthier in terms of they are more less saturated fat like olive oil, safflower oil, canola oil. So you can see all these ingredients in the spreadable butter that you use for your breakfast, for example. Okay, so this oil are mostly plant origin. Macam we have very famous Malaysia is one of the world producer of palm oil, Malaysia and Indonesia, okay, which is being used a lot in food products. Okay, palm oil, then we have coconut oil, olive oil, safflower oil ni bukan kita punya lah. These are all from Mediterranean, US, like soybean oil. Okay, so they are mostly plant origin. Mostly they are unsaturated. Okay, so this oil they have higher content of unsaturated fatty acids. So because of the unsaturated fatty acid, so at room temperature they become oil. Okay, in nature. Okay, for fats and oil for the world supply. Okay, for the world supply, vegetable oil is about 68%. So you see that a lot of in the market, you see that when people use a lot of vegetable oil, including palm oil. And the animal fat are being used in certain types of food products is about 28%, and marine oil ni dari mana? Marine oil ni from the fish oil fish oil are mostly being used as a supplement. Because why? Marine oil ni is not so much being used in food product because one, it is very expensive because you have to extract the oil from the fish. Okay, and also marine oil it is highly unsaturated, so they are more prone to oxidation. Mostly they are not stable lah, but normally people use this for supplement. Supplement kan kita banyak if you see in the pharmacy they will have this marine oil as a supplement, macam minyak cod liver oil, banyaklah they have a lot of this type of oil. So it's about 4% of the world supply. So vegetable oil are extracted on the industrial scale with solvent. This is what I was mentioning just now. So we have to use type of solvent that can extract most of the oil from the source. In terms of vegetable, for example, soya, canola, sunflower. So the oil is mostly in the plant, mostly in the seed sometimes. Seed dia ada banyak higher percentage of oil. So they are being extracted out at an industrial scale with solvent. So this solvent usually is a mix of hexane isomer. Hexane isomer ni not just the hexane, dia ada banyak isomer like C berapa kan. So depending on some isomers, hexane isomers, they will act differently with different types of fatty acid in different types of vegetable oil. That's why you have to use certain hexane isomers for certain type of oil. Okay. Palm oil is extracted through screw press. Maybe you get a chance to go to palm oil processing during one of your courses, right? If you, I'm not sure which course that maybe through your degree you get to see this maybe site visit. If you got the chance, please go to this palm oil extraction. Okay. And that solvent is percolated through a bed of crushed seeds and then distilled off as an azeotrope to leave behind the extracted oil. So you can actually see this maybe in videos in YouTube. Some Dhabi, for example, we have KLK, we have Sam Dhabi is a big has a big share for Malaysian plantations for palm oil. Okay. So this defatted residue used to make soy protein powder. Okay. So this defatted residue. All right. And then we have what are the functions of lipid? Okay, so lipid, we know that lipid is the source of energy. Just like the carbohydrate, lipid also can be energy source and reserve. Okay. So for insulation, for example, so if you compare carbohydrate and fat, 1 gram of carbohydrate is 17 kilojoule of energy. As compared to 1 gram of fat, we can supply you 37 kilojoule of energy. So for diet purposes, in terms of the balancing between the intake and also the energy expenditure, okay, so when the food intake is greater than the energy expenditure, that means you don't use a lot of energy and burn the fat. So this excess energy is stored as fat dalam badan. So that's why during with balanced diet, we also have to expand. We also have to use the energy. That means we have to go exercise to burn the fat or the food intake, the fat from the food intake that we take from our meal. Okay. And then the other one is insulation. We know that fat can be a co-conductor of heat, so fat can help in terms of insulation. Okay, satu lagi, the important thing is structural element of membrane. If you can still remember your science class dulu, you learn about this, maybe you learn about this in biology class. Okay, so in this membrane, normally dia ada phospholipid kan, dekat you have the hydrophobic tail, the head is hydrophobic and then hydrophilic tail. Okay, so this structural element of the membrane, dia ada phospholipid. Like I said, you have phospholipid, you have sphingolipid, and you have cholesterol. Okay, so these are the membranes lah. Okay, so structural element of membranes ada contain all this type of lipids which are very important in the structure. So kalau tak cukup or not enough lipids to be able to build this phospholipid, sphingolipid, and cholesterol, that means the structural element of the membrane will be weak. Okay, and then for functional molecules, fat can be hormones, can also be vitamins. Vitamins, kita ada fat soluble and non-fat soluble. We have the water soluble vitamins. We have the fat soluble vitamins, the A, D, E, K. Okay, and then fat can also be cofactor of the functional molecule. So if you don't have the fat, some molecule may not be function properly. Okay, fat at the same time is a flavor element. So kalau tak ada fat, kita kurang flavor. Okay, so that's why some macam sekarang kan, now people use lesser fat, lesser fry kan. You use air fryer, use different types of maybe you put it in the in the oven, for example. So you can actually feel the difference between if maybe, okay, for example, we use one type of curry puff, contoh curry puff kan. Okay, you take the curry puff and then you fry it in oil versus the one that is used in air fryer. Which one tastes better? Okay, of course, the one that you fry in oil, because oil, other than, of course, it contributes to this energy source, it also contributes to the flavor. So the one that has more oil has more flavor, as opposed to the one that you don't use oil. Kan kalau kita letak dalam air fryer, you use maybe 1 teaspoon or 1 spoon of oil kan. You just use the heat. Most of the heat is being used to fry the curry puff, right? So that's why you can taste that it is not the same, not the same taste, right? The food uses of lipids, okay. One is improve flavor and texture, okay, like I mentioned. Okay, fat can contribute to the flavor and texture of food. Semi-solid character has distinctive mouthfeel. Okay. Fats can act as carrier and other flavor elements. So as part of giving the flavor itself, fat can also act as a carrier of other flavors. Okay. Alright, fats have their own taste and sometimes odor. Okay, this one, different fats will have different taste and odor. Okay, and then moisture retention. Because I'm not sure if you can still recall your water class with Dr. Alia. Because water, they are not just H2O molecule that act on their own, but water can also have reaction, right? Reaction or can bind to other molecules. Because in food system, you have all these macro components that actually work with one another. They either react or they either bind, become a more complex molecule, right? So this fat can be a moisture retention. So kalau ada one type of food that has higher fat, it when you cook them or when you bake them, it can retain more moisture than the one that it has no or less fat. So you know that if you eat some food that tastes more not dry, okay, so you know that they will have fat in it because of moisture retention from the fat. Okay. Frying medium, okay, we know this. And then satisfaction. Satisfaction ni like the one that I compare when you fry your curry puff in oil and the one that you use with non-oil, kan? So it gives you more satisfaction when you eat the one with fat, right? Because one element in satiation or satiety is fat or lipids, okay? So low fat diets are not well tolerated. Okay, this one is or more into satisfaction. Okay, then we go to the classification scheme. So this lipid, like the one that I showed you earlier, okay, it consists of simple lipid, okay, wax, sterol, triacylglycerol, complex lipid, and also derived lipid. Okay, kalau complex lipid ni, here are the phospholipid can be because like I said, if you imagine complex means something that is bigger molecule, right? So bigger molecule macam normally it has something that bounds to it. So phospholipid ni, it has glycerol phospholipid, it has sphingolipids. So these are the examples lah, like phosphatidylcholine, phosphatidyl ethanolamine, phosphatidyl inositol. These are all examples of phospholipid. Okay, and then we have sphingolipids, ceramides, sphingomyelin. Okay, these are component of phospholipid. And then other than this phosphor group, we also have glyco group. Glyco group, for example, cerebrosides, gangliosides. These are all under category of glycolipids. Okay, so these are the general classification of lipid. Okay, so major lipid component, okay, for main types of lipids, major component of this lipid are fatty acid. Okay, nanti kita tengok apa maksud fatty acid. Okay. And then we have acylglycerols or glycerides. Like I mentioned, whether we call it triacylglycerol or triglycerides. Okay, so acylglycerol and glycerides are the same. Okay, and then we have glycerols or phosphatides. Okay, these are the major lipid components, or more than 99% of fat component consist of this component. But there are also some parts of lipid component which is called minor, which is tocopherols. Tocopherols ni apa? normally used in tocopherol and antioxidant kan. Antioxidant normally used in to combat this oxidation lah. Okay, sterols, plant sterols, wax, pigment can